对，三九100，180，是有的。我们其实往这边都可以往。
Okay. First of all, I would like to remind you that 22nd, so the last day for forming the project, and try to make sure you can first form a group of 5 students and then agree upon a topic that you will work on. And if now every semester there will always be students that have trouble to find enough, say, students to form a group of 5 students. And if near the end of the last day for forming the group, maybe we can ask TA Lincoln for help, and he will try to collect all those remaining students that still cannot form the project group, and then if he may say get involved and try to form the group for you. Of course, you will be consulted in order to get the final group. Okay, right. Okay. So just want to remind you, try your best to form the group and pick up a project that either get agree upon with every member. Okay, and then start enjoying the working on the project. And I want to iterate and emphasize that this project is the major component of this course. To be honest, okay, the project is the only way that you really learn something interesting and deep in this course. And not only learn the latest technique or develop your skill, but also get a very good experience to work with other people who have very different background from you. So it is kind of a very good learning experience. We try to cooperate with people with very diversified backgrounds in order to achieve a common goal. Okay, so again, I just want to reiterate that this course is just an introductory course. Okay. So the main purpose is try to kind of skim through different application area of machine learning related to finance, and there are many of them. Okay, so we picked 5 of them, and we have only 8 lectures. You know, and after covering the necessary background, on average, we have only about one lecture or one application area. So obviously, it's far from enough to get into some deep discussion on that. So please understand that what we intend to do is to give you a broad overview on the application on machine learning on some particular area, and just give you some kind of preparation so that if you really want to learn, say, more about this field, learn to use the latest advanced, say, package or tools that are available on the internet, then maybe you can just pick some project topic related to it. Okay, so that you can work on yourself to teach yourself to learn more about that area. Okay, so this is what I want. Okay. Now, because we do not have enough time, so let us get back to our discussion on machine learning. So this gives you a kind of a simplified workflow for applying machine learning on a general problem. And we say that it is a 5-step show it diagram, a kind of a flow chart. So it is, I suppose it is simple enough to understand the workflow. But what I want to explain is one particular feature about this workflow. Okay, it's about the splitting of the data. And you see that basically the first 2 steps is related to getting enough data for us to develop this machine learning application. And then we pick the machine learning algorithm. Okay, so we have the algorithm, we have the data, then just apply the algorithm on this data, then bingo, we have the model and we can use it. It seems very obvious, straightforward. But still, you can see that in addition to this, just simply apply the data to the machine learning algorithm to build the model. That's a loop here. Seems very complicated. And not only that, it divides the data set that we collect into 3 different separate data sets. Why we say make things so complicated? So I just want to explain. And as I remember, I've already mentioned in the last lecture at the end. Say 10 years ago about when machine learning started to become a very attractive topic, so many of our final year students choose this topic, trying to just apply machine learning to various, say, finance prediction problems, such as stock price prediction. Then what they are doing is just the first 2 steps. Collect the data, pick and say very advanced machine learning, deep learning algorithm. Okay, then they just apply the data to the algorithm, get the model, and then back test. Okay, the performance of model on the data, and bingo, they get a the result that the prediction is much more accurate than those predicted by existing methods. So almost all the final year project students will get very excited and will achieve something great. Okay, but at the end of the day, the model they build are totally useless because they encounter a problem called overfitting. So this overfitting problem means that because the model building algorithm build a model that are so powerful that whatever data their model will be adjusted or trained in such a way that the prediction of the model on the training data. It will kind of cover all the data and give every input point the best result to you. Okay, so it makes things look so exciting, but eventually, when we test the student's model on some other data, then the result is very poor, because the training staff adjust themselves so focused on the training data. It just kind of so-called overfeed the model to the training data and forget about the general data. Okay, so now the problem is, how should we avoid this scenario? And this is why this loop is all about. So instead of just feed the whole set of data to the machine learning algorithm, we will divide our data set into at least two parts. Okay, but later you will see that in fact we will divide them into 3 parts. Okay, but anyway, let us divide them into 3 parts first and focus on 2 parts, and then explain what is the usage of the last part. So we are going to divide our data set into 3 parts for different purposes. And this division, as I mentioned again, is to avoid overfitting. Okay. So how to avoid it? So given this data set, I will try to say use 70% of the data picked up from our whole data set randomly. Okay, so get 75% of our whole set of data and call them a training data set. And for the remaining 30%, I will pick randomly 20% of the data, okay, and pick them up, okay, and call this data set a validation data set. Finally, we have the test data set. Okay, so now what we are going to do, as what the FIP students have done, okay, that we will use the data set to train a model. But instead of using the whole data set as the student, okay, have done, we will only use the 70% of data. We call it the training data set. And then we apply the machine learning model, okay, and use the training data set to fit in the machine learning model, and then let the machine model get the best possible algorithm on this data set. Okay, of course, at the end, we will have very good result of this training data set. But our decision on whether we accept this model or not is not depending on the result of the training data set, because we are pretty sure that it will be good. Okay, later you will see that when you do the training. So sometimes if the result is not good, then you can rerun it again, and it's not good enough, then run it again. So you keep on running to get the best result. So it's not that surprising that we get to the good result. Okay, so now after getting the model on the training data set, then we will use the validation data set, the 20% that we get, okay, from our whole data set. Okay, and then we use this 20% validation test to test our model. Okay, so this is very different from the final year students. Okay, so they use the 70% training data set to get a model, but whether this model is good or not is depending on the performance on the 20 validation data set. Okay, so this avoid the overfitting, because the training has not, okay, have not any idea on the validation data set. Okay, so the training, the part, if they can have a good performance on this 20% validation data set, then this 20% validation data set is, say, picked up randomly over the possible sample space, that it is kind of probable that the model will have a good performance in the general scenario, and then we don't need to worry too much about the overfitting problem. Now, this is the best scenario, namely that once you have the model and then test by the validation data set, you get a good result. But of course, life is not that ideal. Okay, so this is what you have seen. Okay, so you pick up the 80% of the training data and then run the algorithm to get a model, and then you use the validation test and use it to check the accuracy of the model. So basically, the model will give some prediction, okay, on for the input, and then based on the prediction returned by the model, and of course, since it is a supervised learning, so you know the model answer, and you can compare the difference and evaluate the performance. And if the performance is good, then bingo, you accept the model and you can live. But if not, that means that the model cannot say give good performance on data other than the training data set. So what should we do? Basically, we just kind of artificially or using some standard method called grid method to adjust the model. Okay, because this model overfit training data, so you just kind of adjust the important parameter of the model. Okay, and then you do the training all over again. Later you see what do I mean by adjust the model and then do the training again. So when we talk about, say, a deep neural network, you have a better idea. Anyway, the problem will be I adjust the model and do the training again, and it will give us a different model. Okay, and then for this different model, of course, we use the validation test to test its performance. Okay, the new model will give new prediction, of course, to compare with the model answer, evaluate again. If this is not good enough, we make some adjustment of the model and then do the machine learning algorithm again, and then get a new model, and then use the validation data to get the prediction, and all again and again and again. Okay, so usually you may take it 10 times, 20 times, or 30 times this route. Okay, so ideally, every adjustment will give us a better result on the validation data set. And at some point, that the prediction, okay, will have a performance that satisfies our threshold of acceptable, okay, accuracy. So in that case, then we can say accept this machine learning model and then give it to the boss. This is the model that I trained. Okay, so this is what we have. Okay, so 70% of data for the training, and then 20% of the data for the validation. Okay, and then we repeat the whole process until the performance of the model trained it will have a good performance on the validation data set. So there's two different data sets. One data set for training and one data set for evaluation. So it will avoid the so-called overfitting problem. Okay, so now you will be kind of curious. Why then we need to use the test trained data set? Okay, just imagine that Okay, this kind of looping can have run, say, 30 or 50 times. Okay. Or such that every new model, when we use it to make prediction of the validation data set, then at some point it's not good, and then we make the adjustment. Okay, so just imagine after, say, this process we repeat 50 times. So what exactly we are doing? What we are doing is we adjust the model so that it will not, say, be satisfied until it has good performance on the validation data set. Let me repeat. What this process really gives you is, out of the 50% of the retraining, basically every time if I find the model's prediction on the validation data set is not good enough, then we make the adjustments. And then if not, again, if the new model is not good enough for the validation set, we make the adjustment. So in other words, effectively, we are training our model on the validation data set also. We get the result, and if it is not good enough, then we adjust it. So eventually, we kind of adjusting our model so that it will also have good performance on the validation data set. So eventually, the model may overfit also on the validation data set. Okay, because this is what you are doing. You want to make the model have good performance on the validation data set, even though the training in or on the training data set. But if the result is not good, then you make the adjustment and train again. So eventually, okay, the whole process also will tailor-make to get good result on the validation data set. Okay, so if this process take 100 times, so eventually the process is effective to make the model train on also on the validation data set. So what is the final step? So after this training, okay, then you want to present your result, your model to your boss. Now this is what we have done. Okay, now you make the decision whether you will use it or not. Okay. So I'm the boss. I know, okay, what you have done. So I also will be kind of skeptical on whether your data set will overfit, okay, the validation data set or not. So what I'm doing is I will use a brand new data set. This is exactly the 10% data set that I prepared, okay, at the very beginning. And then I will use this 10% data set on the model. And the most important point is I will not do any training again. So this is the final, say, judgment. So if your model can get to a good result on this 10% testing data set, then okay, then I will accept it. If not, okay, that's it. Okay, you fail, right? And then you do not need to do any more training. I will just forget about your effort. Okay, so maybe you need to collect another set of data or collect a larger set of data. Okay, but in general, this say original set of data for the training part will totally scrap. Okay, because you cannot pass it. So this is kind of make things more complicated. So you will see why the final year project students are far from sufficient to get a good model. But basically, okay, the real process will be much more complicated. And the important part is the last testing data set. you use it only once. And this is the final decision. Okay, so this is what I want you to understand the reason why we need to divide the data into three parts. And this is very important. Now, this is just a general method to avoid overfitting. As a matter of fact, in recent years, there's also a lot of proposed, say, methodology, okay, that will try to use different, say, reasonable steps in order to avoid the overfitting. For example, a very commonly used step is called multifold validation step, usually a 5-fold validation, 3-fold validation, and that kind of thing. Okay, so this is the process. So let me repeat. Okay, so gather data, data preparation, these two steps, and practitioner in the field basically agree that it will take about 70% of this whole resource of your project, money, the time, manpower, in order to collect the right set and large size of data, and then clean them up, do the exploratory data analysis in order to get the right set of data. Okay, and then we choose a ML algorithm. This is also very important, but for us, we can just pick one and see how it works. Usually, those set of algorithms, there's two kinds. The first is called the traditional machine learning algorithm, or sometimes we call it the shallow machine learning algorithm. That is the traditional machine learning algorithm. For this, basically, the website called sklearn collect most of the popular and proven machine learning model building. Okay, that the user can use them to build your model. So basically, all the variable algorithms can be kind of picked on the website of sklearn. Okay, so later when we talk about different view example, so we'll go to the website and see that they have a large collection of programs for us to build different model, machine learning model building up. Okay, but it's not that many. As a matter, it's about 50 or 60. So this is the point. So even though we can apply machine learning to many different problems, but the different models that prove effective is not that many. Okay, so about commonly used model is about 50 or 60. So you will see. So all you need to do is to pick one of them and then apply the data to train the model. But of course, setting the parameter correctly or pick the right machine learning model building algorithm and set the parameter correctly, basically you need expertise in order to do that. So I don't want to kind of give you unrealistic optimism. Basically, it's not that easy, even though the basic step is not that, say, complicated. But the key point is, if you want to do things right, it is not easy. Pick the right algorithm, set the parameter. When you get into trouble, how to adjust the parameter, okay, and this you need expertise in order to get something that you have a model better than. Okay, so this is what this course cannot teach. Okay, it just gives you a very broad, high level idea on how things are done. Okay. Now we train a model. Then I have spent quite some time to explain the loop here. Then after that, you get a sample model, then you use the testing data, okay, to decide whether you use it. Okay, and now in the next few slides, we will show you some simple example on using how to say go through this process. Okay, by giving you some toy problem. Okay, so the first is on the classical example. Now, this classification, let's say application, is very common problem that you can apply machine learning techniques to solve that. For example, you want to say classify different objects, or you want to classify whether this transaction is problematic or not, that kind of thing. So let us look at this example. It shows you how to apply machine learning methodology to build a model to classify objects, whether it is an orange or not, an apple or an pear. Okay. So suppose we collect the data, we first decide, okay, what kind of characteristic that our collected object should measure. What should we, okay, measure the characteristic of the object to be our data point. So you choose the color, and also you choose the shape, and also you choose the weight, or the sweetness, or whatever. Okay, so basically, when we decide to create this data set, we need to first decide the characteristic. And then whenever we have a new object, we just measure, okay, the value according to the characteristic. So this is preparing the data. Okay. Now, so this is gathering the data. So eventually you have a data frame or a table that every column, every row corresponding to one object, and then each row show the value of the object on different characteristics. So the color of the object, or width, height, label, width, height of the object, and so on. Okay. Now, this is very easy, but basically, collecting the data is also a very important, let's say, skill. Because when you get the data, for example, when you get the data for doing fraud detection, say for example, then you collect all the bank transactions. Then this set of data may not be suitable for your training, mainly because in that set of data, when for example, money laundering, to detect build a machine learning model in a bank to detect money laundering. Then just getting the whole set of transactions of the bank may not help, because if this is the case, then 99% of the transaction will be normal, and only with 1% of the transaction will be typically a suspected case of money laundering. So this widely imbalance between, okay, the normal data and the problematic data, 99% to 1%, it will not, okay, train a good model for you. As a matter of fact, according to what machine learning models are really work, then basically the model will kind of ignore the 1%, okay, treat them as outliers. And then you just imagine that you can just simply give a model that will return no on every transaction. Then it will already give you accuracy 99%. Because of the data, basically 99% is no. Okay, so this model will not be that helpful for you. So what I spend here is, even though I just show it here, getting a large enough set of data and the data do some say processing in order to make it the quality is good enough for training. Basically, you still have to carefully. As a matter of fact, years ago, I'm doing research on bioinformatics. Okay, and then we still work on machine learning prior to bioinformatics. And basically, our major problem is that the data that we get is very small. Okay, we get the medical data and try to train a model to detect cancer, for example. But the sample that we get basically is less than in the range of 2,000. But then it's a few thousand involve a long set of characteristics on the patient's, say, different measure of this hormone and the cell structure and that kind of thing. So basically, the problem is we cannot work a very good model because we do not have enough data. And it's very difficult to get the data because the hospital just kind of reluctant to give us the data because for the kind of the privacy issue and that kind of thing. Okay, so basically, I just want to give you some experience that getting data is a very important and very difficult. Okay, so you can see why the machine learning or AI development in mainland China is much, say, better than those in the United States and Western world. For example, in, say, face recognition. Because in the Western world, the privacy issue, the human rights kind of restrict the AI company to get enough data to do the training. Okay, but in mainland China, okay, you see that all over the place. So data is no problem for the training. Okay, so this is not okay. So the data basically you need to have the balance of data. If the data on 5 objects, then the proportion of the training data should be equal number for every object. Okay. So in this case, we need to have data that balance the color as well as balance the width and balance the height. Okay, so this is not difficult. And also the quantity, the number of data points are also very important. Okay. So how much data is needed to train a model depending on the application. Okay. So for recognize an apple and pear, not too many. If you want to recognize a cat and dog, then basically the data is not valid. Okay. So this is some example here. Once you have get the data, you cannot use it directly in this case. Okay, so you need to work on it. It's called data preparation. And this is kind of what a data science and engineering or data analytical course will teach you. Okay, apply, say, language R or Python pandas, apply the tool to kind of massage the data, throw away the problematic case, and so on and so forth. Okay, so this data preparation is not easy. Why? If you look at this, say, simple data set, you may not really aware. But just imagine you are working on a data set that contain thousands of rows, not even thousands. Sometimes you need to handle millions of rows. Okay, and every row has, say, 10 to 20 words. So it is not possible to show them on the screen. Okay, and not just imagine that you scroll down and try to skim through this million of people is totally impossible. Okay, so this is why we need to have a very different, complete enough skill to apply existing data analytics. At least you need to know how to use the language R, or you know how to use Python pandas, apply the function there skillfully to get the data right, how to transform it, how to delete problematic, say, observation, and so on and so forth. Okay, deleting the problematic observation is not easy. Okay, it is much easier said than done, because you cannot go skim through all the observation. How can you find them and enumerate them? Okay, so this is not that easy. Okay, so this is data preparation. Okay, so you need to do the data cleaning and transform the data. What do you ask by transform the data? So this part is called the feature engineering. Basically, is this is one of the most critical steps in traditional machine learning. Given, say, a problem and object, there's various ways to characterize them. And the best feature learning is basically choose a small number of critical features that is it gives you enough information to distinguish or classify different objects. So it is very difficult and important to determine the right set of features in order that the data will just say we call this feature and give you important information for doing that. Okay, so this is feature engineering. As a matter of fact, before deep learning, basically every new product training, one of their say that they beat the other method is sometimes because they have find a better set of features for the training. Okay, so this is feature engineering. Okay, you need to randomize all that. And then here is split the data. Okay, so basically the percentage is not kind of fixed. Okay, depending on what you want to choose. But usually the training data set should be the largest one, and then the validation data set and testing data set is small and more or less the same. Maybe the validation data set is a bit larger, but anyway, this is what we have. Okay? So this basically also depending on style, on the application, and the design. Okay. Now, the first step is choosing the machine learning model. So basically, this is the area, that needs deeper knowledge about machine learning, because we have different kind of model for machine learning, and some are well suited for image data, some are well suited for natural language processing, okay, and some are for music, and some are text. Okay. For example, if you want to do the machine image recognition, so 3 or 4 years ago, and there's no other choice but using the CNN, the convolution neural network model to do the image recognition, while for say natural language processing or understanding tasks, then you use recurrence network. Okay, so basically this you need to have a good say understanding on the strength and weakness of different models, such that you understand what kind of problem, what kind of data this model will affect. So this is knowledge that you need in order to pick the right, say, ML algorithm. But for say, if you how to say, recently people talk very much about deep learning and deep neural network. Okay, and then there are some older traditional methods. I just want to kind of emphasize that the deep neural network model is not the best model for all possible problems. As a matter of fact, okay, at least my research teach me that, okay, usually the shallow, the traditional machine learning model will be better in many situations. Okay. This is because we do not have enough data. So if you use deep, say, neural network model, basically, if you do not have enough data, then the model build basically is rubbish. Okay, pretty much. Okay, so usually, okay, for general application, when the data is not large enough, then we will use traditional, say, machine learning model. Okay. So this is why I just want to point out that you need experience, you need knowledge in order to decide the learning model, not just the very broad, say, choice, whether I'm using deep neural network model or I use the shallow neural network model. This simple choice also needs expertise and knowledge. Okay? And so you decide which algorithm to use. And in the next few slides, we'll give you some of the algorithm, and then you have some taste on what they will give you. Okay. And as a matter of fact, in the remaining of this slide, we'll give some examples on some shallow machine learning including algorithms as well as neural network model. Okay, so this is what we have. Then we do the training. Okay, that will change the data to get a model. So we don't it just shows you an algorithm for decision tree. But anyway, it's not important. So the training, do the evaluation, and then kernel tuning, okay, and then debate and tune data and so on. Okay, so this is I've already go through it earlier. So basically, this is for avoiding the overfitting problem. Okay, so forget what this is necessary. So this is exactly what I've done, why we need a testing data set, because the validation step keep on doing that. Eventually, you just twist the model to fit on the validation data set. So you see, they introduce the fitting problem, overfitting problem. Yeah. Okay. Now, this is for general. So let us give you an example to how to really pick the algorithm in the existing, say, platform in order to apply it to train a model for our application. Okay. So, usually, we will working on two libraries. The first library is for sklearn for shallow, say, machine learning model. And second one that I'm going to use is called the TensorFlow. Okay. And most recently, there's another, say, library for deep learning. It's called PyTorch. Maybe I'll say keep on the TensorFlow, at least in this semester. Okay. Now, if you decide to use the so-called shallow machine learning algorithm that is not doing neural network, okay, then the source of, say, machine learning algorithm that you can get most likely is from the live and the website called sklearn. Okay, so sklearn, or also known as sklearn, okay, it's a free software library and for Python. And language R also have similar, say, library that you can use. But anyway, let's focus on Python. And This includes shallow machine learning algorithms. So for classification, that means that to classify the object into different classes. Regression, basically, is build a model so that different input A, we can predict the output Y. Okay, and also for clustering, the group of data, depending on the closeness, they divide into different groups. Okay, so initially it's developed by Google in 15 years ago, 2007, and this keep on working on it and introduce new algorithms. Okay, and this is the website. And one of the introduction one of the page. So I just go to the page for supervised learning and show you the algorithm that you can use to choose the website. There are a lot of them. But essentially it's about 50 or 16 of them. So in reality, even though we have decades of research in machine learning and AI, but those say really useful and really give us advanced result tools or model building is not that many. So it's only about 50 or 60 of them. So this is why Google can hire a team of super programmer to focus on each of this model and then write a program, the best program to implement this model, so that by making it publicly available, then everyone can use the best algorithm to build the model. So this is one of the key reasons why machine learning becomes so powerful, useful in the community. Because now everyone are capable of using this technology, the best technology. Okay. So this is one major contribution that we learned to make the best possible implementation available to everyone. So now everyone gets the best possible algorithm, and then all we need is to get the data, which basically you do have in order to solve the problem anyway, and then you use the best model to say train the data and get back the result. Okay, so there's many of them. Okay, for example, there's a decision tree. The method that help us to do the computation, regression, and that. Okay. Now, so let me give you some examples. So this example is what we have shown earlier. Last lecture is kind of build a model that will help us to predict the number of cones of ice cream that can be shown in on a day that the temperature is in 7 degrees. So the data that we have is on a day with 10 degrees. That of course you will not sell many ice cream cones, so we fall them. When the degree is 12, degree 5, and so on and so forth. Okay, so this is a supervised learning. The input data is X, the degree of on the day, and then the corresponding Y will be the correct result that we get observation. So based on this, we want to build a model so that we can use the model, we can decide for any degree on the day, we can predict reasonably how many ice cream cones that we will sell. Okay, so of course the problem is not real focus. I just want to they see how to write a program to build a model that help us to make the prediction. Okay, so here is what we need. Okay, so first we import the PLT library, the basic library for drawing graph. Okay, so it's nothing to do with machine learning. Okay, all the Python, the C program on data analytics, import this for drawing graph, just like this. Okay, NumPy for again, for kind of simple numerical operation. Now this is important. Okay, so sklearn, our old friend here. Okay, and then we just from sklearn a sub-library called linear model. Let's see if I find it. Linear model. It's linear model. Okay, it's a sub-library linear model. That is a linear model that is a machine learning algorithm called linear regression. So I just import it into my program so that later in the program we can call it in order to build a linear regression model. Then what is linear regression? Basically, it's just a standard statistical technique that giving a set of data points, not necessarily 2D, but in general it's a high dimensional data point. Then it will kind of construct a linear hyperplane. So basically, just like a straight line, okay? And for 3 dimension, it's a straight plane, and then for high dimension, you cannot imagine it, but anyway, it's so-called a linear hyperplane. Okay, based on it, you just based on the input data, you just find a linear hyperplane that very close to every point of the input data. Okay, so that it will very close. This plane is very close to the training point, and if you believe that all the neighboring data on the training point are kind of very close to the input point, they are related by a line. So find the best line will give us a very good model for us to predict given any case what we want. Okay, so this is finding this line. Okay. To be honest, if you take a statistics 101 course, basically, I don't know whether 101 course you take it for second year, I'm sure. Okay, by simply using some general simple calculus technique. Okay, you can find out the line. Even any point, you can find out the line very easily. And there's a standard formula you put in the data. Okay, it's very easy. Okay, but for us, okay, it doesn't matter. Okay, we just learn the user interface for us to do it. Okay, so what I want to find out is, okay, building linear regression model. You will learn it in some math course and that course. Okay, so it's not super complicated. Okay, it's just a second year statistical course. Okay, but anyway, someone has written this program for us, so we just use it. Okay, how to do that? Okay, this example first. Here's an example here. In order to test it first, we prepare the data. Okay, of course, data usually is collected from outside, but this is a hard problem. So basically, we create ourselves. So the input X is the 1, 2, 3, 4, 5 days, and this is the degree of the corresponding day. And then another Y is for the just solution. Okay, we have 5 Y, 1 for each day, and then they have to match. First, okay, entering 10, that is as 4. Okay, so they have to pair up, even though they are in 2 different NumPy arrays. Okay, so this is it. Now, I want to point out this. Right. The NumPy array, now this is very important. For NumPy array, is a one-dimensional array. Okay, so just 10, 12, how many are these? Okay, so this is very important related to using machine. Okay. Okay. So for NumPy array, 1D NumPy array. Okay, 1D. Basically is this. Okay, 1, 2, 3, 4. Okay, this is a 1D NumPy array. Remember, okay, there's row. Okay, first row, but 1D basically is just one column. Okay. Now, but however, just imagine that you have a machine model, and then you feed in the data to build a model. Okay, so the data will be something like this. Okay, the first row will be the content of the first observation of the first data, and then so this is for data point 1, and this is for data point 2, and so on and so forth. Okay, to the end. So basically, the input training data, which will be an array, in which each array, okay, each array entry will be a row, okay, for each observation of the data, the features of the data. So in this case, that means that it should be a two-dimensional array, okay, such that each row will be a corresponding observation of the data. Okay, so its shape should be, okay, for example, is number of observation times number of features. So the shape is 2. Is it clear? So it should be a table, two-dimensional array. Every row corresponding to the observation of the data. But if you see this one-dimensional array, okay, it's one dimension. Okay, so if you want to feed it into machine model, it doesn't match the requirement. Okay, because this is one-dimensional array is 1, 2, 3. So basically, you need to reshape it into 2 dimensions. Okay, so now it's kind of very difficult to understand. So basically, maybe let me try. Instead of one temperature, suppose every training had 2 temperatures. Okay, so it's temperature 1, 4, 2, 5, and 6, 6. Okay, suppose we have 3 measurements, and then each say a date we take 2 measures, say the temperature of the morning and temperature at the night, and so on. Okay, so this is the data, and then we just feed it into the model, and it is a, yeah, you can see it. Okay. Okay. So basically, I want to show that what I want to show that is the data should be a 2-dimensional array, such that each row contain, okay, the data for one particular data point. The key point is it will have multiple columns because it has different features. So what I want to say is most of the machine learning model building algorithms expect that the data is 2-dimensional array. So every row corresponding to one object, and that each object contains 2, okay, several number of features. So it's 2-dimensional array. No matter what is the actual data, it requires 2-dimensional array. Okay, now if you go back to our example here, Okay, when you create this array here, number array, this only create in one-dimensional thing because you just give a list of data is one dimension. Okay, so given a one-dimensional array, you need to reshape it into two dimensions. Okay, because when the programmer write this, say, machine learning algorithm, they expect the general scenario in which the data will have more than one features, many of them. So it expects the input is two-dimensional array. Okay, so this is only the stupid or simplicity of this problem that each data point has one single, say, feature. But still, we need a two-dimensional array. Okay, even though each observation here is one single number, okay? But we still need two dimensions. Okay, is it clear? So this is a one-dimensional array. We want to reshape it into two dimensions. Now, but the two-dimensional, basically, we need to specify the number of rows and number of columns. Okay, it's the shape. With two numbers, number of rows and number of columns. Okay. So how many columns are there? Only one. Temperature. Okay, so this is the number of columns should be only one. Okay, and how many rows? You count it yourself. 1, 2, 3, 4, 5. 1, 2, 3, 4. So should we shape it in a column or shape 5 and 1? Is it clear? So 5 and 1. So in general, if you write a program, the data may not be 5. The input data will be 12 or maybe 11 or 100 and so on and so forth. So basically, this reshape will depending on how many rows are there, even though the column must be 1 in this example. So this program is kind of, if you write it this way, this code is kind of stupid because whenever you want to run it for a new set of training data set in which the number of points is different, then you need to actually change number here. Okay, so if the data set has only 5 days and you put a 5 here, okay, and you delete it and change it to 5, if you increase the time, you increase the time. Okay, so of course, this is not ideal. So Python allow us to, okay, put a -1. Basically, because the number of points here is 8, and we know that this is one column, so we can immediately decide what is the value here. So if it is 5, it must be 5. If this is 10, it must be 10. So you don't need to specify in the program, okay, because it is already there. Okay, so in order to say allow us to allow to -1, okay, for this number which can be decided by the program easily. Okay, so this is very important. Now you will see this kind of say reshape many times in the example of this code. It's mainly because the program or the machine learning model that has been developed is kind of handle general case in mind. Okay. So basically the input is quite complicated, but the example that we work on will be quite simple because they are quite problem. So the data that we have, okay, is not exactly meet the requirement of the input data format of the algorithm. So we reshape it. But the reshape process is kind of straightforward. Just add one more dimension without making anything. Okay, but I just want to then once we prepare the data for something that we need, okay, that's what we need. You will see now that the way to create the model and use it is kind of uniform in the sense that no matter what learning model that you want to build, and if it is in sklearn, they basically follow exactly the same semantic. Okay, so you call the name of the library or the function linear model to build a model that is okay initially for building a linear model. Now this fit for training. So no matter what the model here, you just model dot fit, okay, to train the data. All you need is to give say input data 8 together with the corresponding label 1. That's just answer. Then after that, it will give you a model. Okay, now forget about this one. Okay, basically this one is I just want to show that these two steps can be combined with one single step very easy. Call linear regression, create a model, and then basically call the fit function to do the training, and then you have a model. After you build a model using these 3 lines, then you can make the prediction. So the prediction basically is called model.predict. So the model is the one that you have just trained it, and then you give the input data here for make the prediction. So in this example, I use the original X and make the prediction. So we have the Y predict storing the result of the prediction of the model that we build, while Y is the correct model, correct result. So we just need to say compare the difference between Y and Y predict, and we can compute the accuracy of the model. Okay, and here it just show how to draw okay the data point and just look at how to compare. Okay, so now at this point, okay, basically we have made the prediction. Okay, so all we need is to compare the Y and Y predict to get a better idea on how accurate is the prediction. But the line here is just shows them for the diagram to give you more here. So PLT is the standard, okay, that tools for us to draw diagram. So I figure okay, specify okay the size of the figure that you need to draw. Basically, is the x coordinate is 10. Vertically, horizontally is 10, vertically is 6, so this box, so the point will be drawn between this box. And that is a function called scatter, the PLT library that will put okay, the point x and y on the 2D plane. So this is x and y, you have a point here. This is x and y, you have a point here, 12, 5, 12, 5. You have one here, 16, 7, 16, and then 7. And you have one here, 12, 2, 4. Okay, so the blue point, okay, will be kind of showing the XY point of the original data. And the next is also scattered. Okay, but this is for the prediction. Okay, so the blue point are the correct answer, while the red point are the prediction. So which say that with 10, if predict is 3, 12, if predict something smaller than 3, and so on. I think the red point are the prediction. Okay, so you see that the red point and blue point are very close for every X. Okay, so this is what. Okay, so now here basically is to because this scattered point we can allow specify the color of the point. So in order to make the distinction, the first scatter point I use the default color which is blue, while the second for showing the detected point, you convert the color to red. Now the last 2 lines is for drawing the straight line. Okay, that pass through all the predicted points. Okay, so basically it's the function called prop. So for part basically you give the x and okay, and the y, and then you draw a line, okay, pass through that, okay, and if you still remember this line space, x mean and y mean, x mean and y mean, you divide this range x mean 10, y mean 20, y max, x max 26 divided into, say, a regular interval of 15 here. Okay, so allow us to very small. Okay? And finally, we need to recheck it in order to so that we can count of object points from that. Okay, so you try yourself. Okay, so this is kind of so this part is not project. Okay, it's really start how to go apart. So this 1, 2, 3, 4 now is most important. Okay, you give the prediction after you train the model, then you call predict, then you give the data and you get the prediction of the model. So this can be a NumPy array, or it can be just a simple number. Okay, to give you the prediction of that the number. So if the temperature is 30, then if 30, it predicts that the number of atoms cell is 16.6, around 90 more. Okay, so this gives you an example on build a linear regression model for solving the classification problem. Okay. I don't have time to go through it, but anyway, basically it's also very simple. Okay, so you give input for the feature now is not a single number, but the features of the object, which is an orange, apple, or pear. If you remember, we have 3 numbers for every observation here, 3 numbers. So you can see that the number input is a 2-dimensional array. Okay. Number of objects and each object is the number of features. And then the corresponding and another model answer. Okay. 0 for apple, 1 for pear, and so on. Okay, and then just like this one, we call a decision class. Now, in here, I'm going to call the discrete decision tree classifier. Okay, to build a decision tree to how to build the model. Okay, basically, build the model, and then we call fit to train the model for it. We give the data in this form, and then the corresponding model answer and label, and then we will have the model. To classifier. Then after that, we just do the prediction, and then give the input array, and then we give the stuff. Okay, so basically, I just want to show that it's very simple. Okay. It doesn't work. That means that I need to take a break. Okay, so let us take a about 15 minutes break, and then we return at 8:30. Okay.
您能听懂普通话吗？
还有一个
那个我想问一下，就是那个 project 是我们就是随便去选题目，还是说就是当会有题目自己选？啊，那就是对房价的预测可以是就是
很多 past say projects work on this that's a data set in Chicago okay
就那个
Boston
对
work on that okay that will be fine
那个就是我们选择的机器学习算法会影响我们就成绩吗？因为比如说SVM 肯定比 linear regression 要更难一点
啊。
那对于算法的研究选择会影响我们。会，
所以就是不用 linear regression， 就是说 kind of 是。
那假如比如说我们就是不在调用库的情况下自己去实现，比如说 linear regression 这样算法，那这样
也可以。
这样就是会有帮助。
帮助的是 marks
对 marks，
很难讲，因为 linear regression is too simple。Maybe if you try other more complicated algorithms, implement yourself.
Like decision tree,
yeah,
ID tree, will this be exact? It's simple as well.
It's also quite simple. Maybe you can pick some paper, okay, and then it's that difficult, but it's from recent paper, okay, and then implement it, and that's good enough.
Okay.
Because all those algorithms, you can find the implementation, the code in some other textbook.
Yeah.
Okay, so it really can't tell whether you really say implement yourself or consult other textbook to put it into the implementation. But for the paper, usually, okay, even understanding problem is another solution. So it definitely helps to get a good code.
Okay. Thanks.
Professor, I want to know who is the PA. I want to ask
Lincoln.
Yeah, has he come in?
No.
Oh.
Let go ahead.
Okay, no. The information is
yeah, you're right. Just send an email to him.
Oh, okay.
So if he doesn't reply to you, send an email to me.
Okay.
And I'll grab him.
Thank you very much.
Okay.
Can I know? I heard that you can send some revisionist paper.
Yeah, right. Yeah, right. So for your project, so pick some recent paper, learn the most kind of the frontier technique, and then try to explain it. It's already a you go for art. So it will give you a good. It's kind of very flexible. So if you really like, then after you decide what you want to do, then you can come to me. Okay, you can kind of confirm that this is exactly what. Okay.
Actually, you mentioned we can use Scikit-learn or TensorFlow to implement our project. If I want to use PyTorch, let's say,
Of course.
it's okay.
Of course. Basically, in the next semester, I will change the course. TensorFlow is kind of not.
Yeah, because PyTorch is more popular now.
Yeah, right.
Okay.
我想問我今個禮拜一先至嚟 roll 到呢一堂，咁我都覺得自己難啲揾到 group 未，係咪之後你會即係有啲人冇 group 嘅興趣？
會。
OK，咁我應該
係啊，如果你或者係咁講啦，你想早啲個 TA 幫你咧，你 send 個 email 俾個 TA，咁你話俾佢聽你有 problem，咁佢哋早啲幫你揾啦。
係，甚至乎其實自己一個人做成數咯。
咁我哋好難俾分咯。所以最好就係大家都係咁高，咁但係冇可能嘅，咁但係就我哋盡量希望可以大家個 number 個 size 一樣，咁我哋比較易 compare 啲。
會唔會即係向 student 自己，即係你會唔會即係個 grouping， 即係如果剩翻咗啲 part-time student 會翻埋一齊？
但係最好就係你早啲同你 TA 講，咁將你成想法，咁我就比較容易幫你。
OK， 我容易啲幫我。OK， 我同個 TA 講。
好啊。Okay. Okay, so let us return to our discussion. Okay, so finally, the example will be on unsupervised learning. And for unsupervised learning, then we will make use of a very classical algorithm to help us to say cluster all the points from different groups. It's called the K-mean algorithm. K-mean algorithm. Okay, so what does it do? Basically, the K-mean algorithm, the K is the parameter that you specify. We have 2 mean, 3 mean, 4 mean. So in this example, basically, we are working on a 4 means. What does it mean by 4? So you can see that we have an input data here. The point, each point corresponding to 1 particular data. Okay, and then they are distributed on a 2D string. What we want to do is to say divide or partition this whole set of input points into 4 different groups, such that the points in the group are close to each other. Okay, so if you intuitively you see this point, then of course this group of points belongs to 1 single group. Okay, they are close to each other. This is another set of points, and so on and so forth. So basically, we are going to use the so-called K-mean algorithm that the input will be a set of points, Now, it can be in 2D plane, 3D plane, and so on. But in our example here is the 2D plane. So that's a set of points in a Euclidean space. And then the output of this K-mean algorithm will group the point into 4 different groups in this example. And then we will see whether the grouping are correct or not. Okay, so let me go through the program. Okay. Now, here is the program. Just try to run it. So first, in the first cell, we just import, as usual, the standard library, the PLT library for drawing, the NumPy library, the Pandas library, and then the PLT library. Then you can see that that's a sub-library called Seaborn, and it will help us to draw the clustering. Okay, so run it. Okay, now. After that, so this is for the standard drawing and data analytics. And for this cell, basically it import from sklearn the sub-library cluster, the function called the sub-library called K-mean. Okay. Now for this, basically, this part is not about the machine learning. This is about the generation of the data. Okay, it just so we just from the sklearn dataset library import this make block. Okay, so a function. This function is just allow us to draw random point on a 2D plane. Okay, so each point is called a block, B-L-O-T, and then you draw it one by one, B-L-O-Bs. Okay, so how to call it? Called make block. Okay, and then n sample, number of sample here. I want 100 point, so it's 100, and I want this 100 point to be grouped into 4 centers, so it have 4 here. Okay, this random state basically, because every time if you do not specify this random state, then every time the initial state will be kind of random, so that you run the same program another time, then the point will be different. Okay, because this is truly random. But of course, when you develop your program and evaluate your program, you want to see how little change of the parameter will affect the output. So basically, in the development, you want the initial input should be the same. You don't want your initial input will be different when you run the program differently. Okay. So that's a kind of 2 conflicting requirement. The first requirement is you want the point to be random. And second requirement is you want every time you run your program, you get the same set of random point. Okay? But you can do that by just specify the random state to a fixed number. Okay? This fixed number basically is kind of the initial state. Based on it, then the program will execute a sequence of so-called pseudo-random steps. Pseudo-random means that it is not exactly random to get you a pseudo point. It's deterministic. You write a program, but it is implemented in such a way that the output look very random. Okay, so you run it in. If you do not specify the random state, then it will pick some, say, the clock today's state in order to specify the initial state to make the pointer truly random. Okay, but if you want to say get the same set of random pawn, then you just initially ask the program not to use, say, the current time, the current day, in order to make the random pawn, but start every time using random state to be a fixed number. You put it here, we call it 500. Okay, and the last parameter is the cluster standard, okay, deviation. That means that how close and separate of this point. Okay, and this is for generate the input distribution of the data. Okay, so this you get, okay, all the extra pawn, and then at the same time, so this is the input pawn. Okay, totally there are 100 of them. Okay, and also if this also different and why, because you're telling that you create 4 centers, 4 clusters. So for each point, then it will tell you which cluster that the point belongs. Okay, so it gives you the Y here. So it's the first point belongs to cluster 1, second point belongs to cluster 1, and so on and so forth. So this basically, this function gives you the training data, the input data set. Okay, the set of pawn, 100 of them, and each pawn, okay, the model answer will be which cluster that this pawn belongs. Okay. Okay, now I just jump a little bit ahead. So after drawing the pawn, basically I can print out, okay, the data pawn. So maybe I just do it, okay, one by one. Now here, so we have the input pawn, okay, and now we train a model, okay, and the model that I'm going to use is from sklearn, is called k-mean. From sklearn, we call k-mean. So this is a model building algorithm that will give them the pawn. It will decide how the pawns are, say, grouped together into different states. So in order to call it, so build a model, basically the n cluster, it just specify the number of clusters that we want is 4. Okay, and then set the random straight to 0 to make sure that every time we run it, it will give the similar result. Okay, so after building the model, we input the data. For training, the data is the pawn, this pawn. Now remember, this is the pawn, this is the model answer. Now I feed this pawn into the model training, okay, and get the model trained by this pawn, okay, and then I feed in the data X, okay, to see what the prediction of the pawn that this model gives us. So basically we have 2, okay, so this is the model answer, and this Y underscore is the predict. Oh, then run it. Okay, so here, and then here, and then here. Okay, so the prediction. So you see that the prediction are a little bit different. The first one is 1, while the prediction is 0, 1, and 0, and so on. Okay. Sorry. Okay, so the prediction is not important. The only important point is whether 2 pawns in the same group. So if in the original, say, input, the 2 pawns are in the same group, then if the 2 pawns are also in the same group in the prediction, this is already very good. Okay, the numbering of the group is not important. Okay, the actual grouping is important. Okay, so this is a little bit. Okay, so now I don't want to go through it, but anyway, this part is to draw the figure for the input data set. Okay. So it is so basically it is the data point 0 is for the x coordinate. Okay, 1 is the y coordinate. So basically it's the xy coordinate for all the data point. Okay, and then you use the function scatter plot to plot the point for this xy point, and here is the result. Okay, and now this plotting also tells you how to assign a color to every point depending on the output in y. So in y, basically here is the first point is y equals to 1, second point y equals to 1, and so on and so forth. So each number will be corresponding to a unique point. So basically for y, then the point all 1 will be orange here, and then this is for cluster 2, cluster 3, and cluster 4. Okay, so this is for printing the data point, and this is for showing the prediction. So now cluster point is for prediction. So the xy point will be the same set of points, but the prediction here, okay, shows you, okay, how the algorithm will predict it for you. Okay, so to be honest, if I look at the table, I will think that the prediction, okay, it gives us a better grouping of the data. Okay, but anyway, sometimes the data input is kind of ideal, not ideal. Okay, so it may not really, even though two groups are very close, but eventually belongs to different groups. So it assigns different data when it is constructed. So basically, this is the real data, and this is the prediction. Even though I feel that the prediction will give us a better grouping of the data, but the real data is exactly how the data is generated. So, okay, so this is what we see here. Okay, any question? Okay, now, since last year, some of the students asked me, okay, they heard k-mean algorithm, okay, many times, so they just want to ask how this works. It's not that difficult. Okay, so let me explain the idea. So what we really want is, suppose k equals to 3, say for example. So give us a set of points in the 2D plane, then I want to group this point, okay, into 3 groups. Okay. So in order to solve this problem, we first need to formalize it, okay, in the mathematical way. So what do we mean by I want it to divide it into 3 groups? So which kind of grouping is good and which kind of grouping is bad? We have to specify it. But obviously, the grouping, so basically, for every grouping of the point, we can compute the total distance, total distance of pair of points in every group. Okay, so this group is 5 points, then every pair of this 5 points, okay, of the distance, then we sum them up. So this is the total distance of points in the group 1, total distance of pair of points in group 2, and total distance of pair of points in group 3. Okay, so in order to make the, say, what we really want is we want to group the point to make sure that the point when close together will be at the same group. So this will be translated into those points, the pair of the distance of every point of every pair of points in this group, is minimized. That means that all the points in the group are very close together, then the grouping will be good. Okay, so this is kind of reasonable that what we want the grouping will be. We want to divide the group of points into 3 different groups, such that every group, the total distance between every pair of points are minimized. Okay, so this is what we originally want, but this is proven to be very difficult to solve. Okay, as a matter of fact, we believe that no efficient algorithm can solve this problem from a very large number of points. Okay, so for the k-mean algorithm, basically it just reduce the requirement a little bit. Okay, so basically this k-mean algorithm is to decide 3 points. You want 3 groups, not the grouping. 3 points, decide the 3 points. Okay, and then for every input point, then we compare the distance between this input point into these 3 design points. And then it will match to the point, the third point that is the closest. Okay, so maybe this way. I'm talking about the grouping. Okay, this is the k-mean. So, for example, you have this kind of point. Okay, so we group. Okay, so I want to divide this point into 3 groups. What I'm going to do is to design 3 center points, so-called, on the plane. Okay, on the plane. Okay, now remember I'm doing the grouping. So basically, for every point, I want to decide to which group it belongs. And every center point kind of corresponding to 1 group. This closest to this center point, so basically it belongs to the group of this center point. Okay, this group closer to this one. Okay, so it's close to not this one because the distance from here is not. So basically, this 3 point will be assigned to a group, that determined by this center point. Okay, and then for this is closer to this point, and then this 3 will be in the same group, this 3 in the same group, and this 3 will be in the same group. Okay, so this is called the center point algorithm. So what we really want to do is the grouping will be determine 3 center points. Once we determine this center point, then we go through all the input data point, find the center point that this data point is closest, and then assign it to the center point. Okay. Then basically, after the assignment, you can have the grouping such that all the points belonging to the same center point will be the same group. Okay? Okay. Now, so this is the idea. Okay? Now, instead of going through all the points to decide the group of grouping, so now we only need to decide 3 particular points in the grouping. Now, of course, it's still not easy because how can I decide the point? Okay, so basically, we will try to use the common strategy of algorithm design. It's called incremental improvement. Okay, just like training. Okay, we give a random say model and then use the data to train it. After that, we adjust the parameter. Okay, and then do the training again. Okay, this exactly follow the same strategy. Okay, because it's the ML algorithm. So this is not okay. Surprising. Okay. So what we are going to do is to first, now suppose we have these 3 different points. Okay, so what we are going to do initially, we know nothing, okay, about the correct position of this center. So all we need to do is to randomly pick 3 on the plane. Randomly pick 3. Okay, and then we follow the same strategy for every point. So which one is the closest? So this one closest, this one. Okay, and also this one closest. Okay, this one, this one, this one. Okay, maybe this one is closest to this one, this one, this one. Okay, so basically, so this is the initial center, center that I pick randomly, and then I can, then from it I can get the grouping. Okay, and this grouping are here. Now, for this grouping, that's one very important point is we have to make improvement because these 4 points are very close to this point already. So at least they are close to something. It's not random. And this point are close to this point. The only problem is the position of this center may not be the right point. Okay, but we group the point already. Okay, but then we want after we improve the grouping, now I want to improve the center point. Okay, how to now this is the important part is how to get a better center point. Okay. To get a better center point, right? The obvious is to kind of in this group find the center point of the new center point. What do I mean like this? So suppose, okay, this 4 point, okay, based on this center point, just like this, okay, and in order to find a new center point, what it is doing is called what is K mean. What is mean? Mean is the average, okay, average of the x coordinate and average of y coordinate will give you a new center point. So basically here, you have the x coordinate, find the, say, mean here, average point, basically is here, so it's the x coordinate, and then for the y, you get the average of the y coordinate, okay, and then you get, okay, the average, and then you get the center point here. So this will be the new center. Okay? So this is what we got. So, first random center. Then every point match to the closest center. Okay, and then those points match the same center belongs to the same group. This is first. Now, in order to get a better center, we look at every group. And then for every point in the group, we look at the x coordinate, okay, and then get the average. That is called the center point. And look at the y coordinate, get the average or the mean, okay, and then we get an average y, okay, and then this mean and x mean and y mean, okay, get some center point in the middle of this group. We do it for the different group, okay. So now we have another set of center points. And experience show that, empirical show that usually this new set of center points are kind of a better choice of original. Okay, so we have another better, say, center point. So we in turn have a better grouping. Right? We should not stop here because now we have a better center point to start with. So why don't we repeat the process? The group gets the new group for the new group, get center point, then we group such that we check all the points again, and then find the new center point that is closest, assign it to it alternatively, and then every point, the new assignment, that every point assigned to the same center will be in the same group. After that, we have another grouping. Okay. And then this grouping is in general will be better than the previous one. It can be proved. Okay, so what should we do? Then, based on this better grouping, you get a better center point, and then do the grouping again. So we repeat it every time. We will have some better grouping. Eventually, where should we stop? Maybe you decided that you do it 100 times and then you stop. Or if you at some stage find that this step will not make any change of the grouping because when you repeat the step and then the grouping is still the same, then you can stop. Okay, so this is the K-mean average. So why it's called mean? Because the center point basically is the mean of the x and the y x coordinate and the mean of the y coordinate of the group the point. Okay, so this is the K-mean average. And this gives you the general step. Okay, so this is what we have. Any question? Okay, so finally you can reach. Okay. The example that we worked on so far are from the library called sklearn. And this library contains machine learning algorithm or model that belongs to the traditional machine learning model. Okay, but recently, of course, everyone knows that there's another very powerful new model is called the deep neural network model. So what we knew in the following example, we just showed you how to say apply this technique for us to recognize handwritten digits. So I just to build a neural network, train it so that eventually it will help us to recognize every handwritten digit. So, and basically, the way to implement a neural network is very complicated, let alone to train it to do the optimization. It's very complicated. But again, fortunately, kind of the problem is kind of well defined. So once we can say specify the architecture of the neural network, then the way to train it and find the optimal model basically kind of follow the same program. So a group of programmers group together from Google, so-called LinkedIn, develop a library called TensorFlow. That this TensorFlow implement all the very complicated advanced programming that help us to give them the neural network and the data, and then the program will automatically solve the mathematical optimization problem to decide the parameter of the neural network to get a best model to fit okay, are training data. Okay, so this is the TensorFlow will be the library that we use. Okay, that help us to implement algorithm for training, building and training neural network. Now, another point is this TensorFlow, even though it already solves a lot of problems, but it is very difficult to use it because the tensor basically is kind of a mathematical object, okay, just like a matrix, but a high dimensional matrix. And the neural network, the definition, construction, or the operation are working on this high dimensional matrix. So if you follow a very deep training in, say, the tensor analysis, it is kind of difficult to handle. So next, another, say, safer will be another, say, super programmer, they write another library called Keras. That's this Keras just reaching our concept of the neural network to the real implementation or specification of the neural network in terms of the sensor, okay? The high dimensional matrix. Okay. So basically, what I want you to see is that we are working not directly on TensorFlow. We will work on a library called Keras. And this Keras, you will see in a moment that it will kind of provide us an API that allow us to specify intuitively, easily, the neural network, okay, step by step. And then after that, then we can call it to do the training. So eventually, the way to build a neural network is just like playing Lego using cubes. We just specify the bottom of the neural network, and then specify the next layer and how the input are connected to the output of the layer, second layer, layer by layer, and then specify the neural network. How this neural network should be represented by a tensor is none of our concern here, because the Keras main job will be, okay, understand our intention and then convert it into the necessary tensor, okay, specify this network. After that, we just give it to TensorFlow to do the training. Okay, so basically, it's what we are going to do. So now, what we need to learn is not about TensorFlow. We don't teach TensorFlow. Okay, of course, when we will take a deep neural network course, then that's TensorFlow will be making topic. Okay, so for us, okay, we will work on Keras, another higher level that will focus on specifying the structure of the neural network. After that, TensorFlow will help us do the remaining parts. Okay, so this is what we are going to see. And yeah, many of you has already mentioned that, okay, recently, there's another tool called Python. Okay, it's kind of easier and more efficient than TensorFlow. Okay, why don't we work on it? Okay, I always want to work on it, but I'm too busy, sorry. Okay, so I promise next semester I will rework all the notes, okay, so that the example is using Python. But at the end of the day, we will not see Python directly, because again, okay, Python is also based on tensor, okay, but using that will make the program theoretically will be much faster to run. Okay, but for our hardcore, no good. Okay. Anyway, let us give you the final example. Now, this data set make a very great contribution to the advancement of machine learning technology because it is a kind of a major problem that every year the researcher in the machine learning community work very hard on solving the problem different years. Okay, so this every time this kind of the competition propel the research to develop better and better machine learning algorithms to solve this, say, machine learning problem. But their results become applicable not only to this recognition problem, but to any other, say, application area, much broader application area. So this problem is kind of very important. So what is this problem? This problem basically is the computation. Basically is the organizer of the computation called domain that prepare a data set called MNIST data set. Basically, this data set contains millions of handwritten, say, image of digits 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so you see that that's okay, millions of data. Okay, how many of them? Okay, 6. Yeah, maybe I'll check it later. So a lot of them. Okay, so in this data set, you have the capture all possible, say, variants of people to say write digit fast. Okay, if you look at the result, it's kind of interesting. So basically, in the state, okay, so citizens write the digit is very different from those from Hong Kong, say for example. So you find that there are many different ways, right? Okay, based on this data set, we build a machine learning model algorithm to recognize this data set. So in other words, we have a classification problem, okay, such that the class will be 10, number of classes 10, from class 0, 1, 2, 3, up to 9. Okay. Now, the input will be these millions of digits, a picture, the image, the input, and then for each image, then the corresponding label, the model answer will be the correct digit that this image represents. So for this image for 5, this image for 1, and so on and so forth. So this is a large set of data. And we will feed into machine learning model to build a model to understand this, say, classification, such that given any, say, new image, this model will suggest whether this image corresponding to digit 0 or digit 1 and so on. Okay, so this is the computation. And here give you over the years how things go. Okay, and as a matter of fact, in the earlier year, basically, that this input data set, then each the partition of this computation will try to train a model using this data set to get a model, and then there's a testing data set to see how accurate their model will get in the testing data set, or we check the error rate, how many errors. So initially, you see that using some simple classifier, linear regression, okay, and random forest and that kind of traditional method, the kind of error is very large, okay, 7.6, 3.3, okay, so this is for the winner at that year, early year, okay. So that means that 100 100 digit, okay, that will make an error of 8, okay, near, okay, 10% is very large. And then over the year, we see that it improved the error rate, okay, quite significantly. Okay, okay, significantly. And as a matter of fact, if you go to the latest one that I show here, like based on neural network, this kind of, say, error rate, people say that is even better than human. Okay, so this is if you are interested, you can go through the reference here. I don't have the reference, but anyway, you can check it, okay, and the internet to see, okay, the related competition result. Okay, but anyway, let us see how to use training data. Okay. Now, I find that recently the code is very slow. Okay, it just take a long time in order to download the package, and then the running is very slow. So now I'm decide to run it the same program. Okay, of course, into my local Anaconda. Okay, so they are more or less the same. Okay, but I run in my local computer. Okay. Okay, so this Jupyter Notebook basically is to use a TensorFlow appearance to build a machine, a neural network model to train the MNIST dataset to recognize the handwritten digit. Okay. So what is important is to show how to, say, construct the neural network. Let's go through it once again. Now, we have the usual library, okay, NumPy, but this is for plotting. Okay, now the next tool is important for us to create the neural network. Okay, from curiously input, okay, a model library that allow us to build different model of a neural network. And then we also from Keras input a library called Layer that will help us to construct the model layer by layer in the neural network. Okay, and we will also from Keras, okay, it is okay, have a kind of education in mind. So it provides data set for us to try the function. So in this data set, one of them is the MNIST that I mentioned. Okay, so this is the handwritten image together with the model answer. Okay, and for here is two categories. Okay, I'll explain it later. Okay, but anyway, this is for utility. Okay, so okay, so that's it. Okay, now here we in order to get the data, then we need to call after importing MNIST, we call load data. Then the result is very nice. It will automatically divide the total input into two groups. Okay, the training data set as well as the test data set. Okay, it will not have three groups, but only two. Okay, train data set and test data set. Okay, because the neural network basically is give us, okay, will do the validation itself. But anyway, this is training data set. Okay, each training data set will contain the image as well as the label. Okay, so Okay, then you will see, okay, there are 60,000 image in the training data set, and each image corresponding to, okay, 28 pixel to 28 pixel. Okay, it's 28 by 28 pixel as the image. Okay, and of course, it will have 60,000 for the label. That is the image. It will be 0 image. It will be 10 and so on. CS1 and so on. Okay, and then there's another 10,000 for the testing image together, 10,000 for the model answer. Okay, so this is the data set. Okay. Now, let us get some idea on what this data set looks like. Okay, so let me see the result and then I explain. The first is getting the training image, set the training image. Okay, and then I just want to look at the first image. So I just get to 0 the first image. That you see that basically is a list of 25 lists. Okay, each will have 25 number. So each row will have 25 number, and that's totally 28 number, and totally there are 28 rows corresponding to a picture with 28 and 28 pixels. Okay, and each say number corresponding to the grade level of that pixel. Okay, the grade level is represented by number from 0 to 255. Okay, so now you look at to imagine that this is a picture. Then you can see that the first few row has nothing on it. They are all white. Okay, and at some point they start to have some color on it. Okay, so the level will be higher. Okay, and then somewhere in the middle, then the color will be the darkest. Okay, and then it will see it. So this is the picture. Now, of course, it is kind of better to know, okay, what is the picture will really look like. And basically, PLT has a function called image show that will help us to display this 28 times 28 matrix of 0 and 255, okay, into an image. Okay, so basically, if you show it, then this corresponding to this image. Okay, and if you print the model answer given, okay, model answer given, okay, label 0, then you get is 5. Okay, so this is the data set. Okay, so you just imagine that the data set is every point will be this huge, okay, two-dimensional array of 28, and then together with the suggested label. Okay, now here. Now it is the reshaping of the let me run it first. Okay. Now we need to do something about the test image. Okay. First is the image is not what we want, because you can see that the image is a two-dimensional image. But the neural network, basically what we want is so the neural network, okay, the model building algorithm, the input is always a sequence of number. Okay, so this is what we expect. While our input is 28 by 28 rows, so it's 28, 28, 28, 28. Okay, so just imagine that the neural network basically, okay, every input is one single number, so totally it needs a sequence of number as its input. But now our training data is really as an image, such that it will just show us row by row. Okay, so but of course it doesn't really matter, because now we can just linearize the row by row such that we append the first row to the second row to the first row, and then the third row to the second row, and then make them into one single list. Okay, and that basically we can just fit this single list to the neural network, okay, to fit the input environment. So in other words, okay, the original input is a two-dimensional data. Okay, basically is it's not two dimensions, sorry, it's three dimension. Okay, because okay, is first dimension corresponding to okay every image, while this image basically is a two-dimensional is an image. Okay, totally it is 600,000 image, while each image is a two-dimensional. Okay, so effectively it's three-dimensional. Okay, but anyway, we can say convert it into two-dimension. Totally still 600. Okay, but then it will now become 28 times 28. So that we just linearize every one of these in a single line. Okay, so basically what we need to do is to reshape it, okay, this image, reshape it into a new shape. Okay, that has 600,000 rows. Okay, but now it's not a two-dimensional array, but one-dimensional array, but the number of points is 28 times 28. Is it clear? Okay, so just okay, out of this 600 data image, each of them is a picture, then we'll just reshape it, the same 600 different image, but then the 2x2 matrix image will now linearize into one-dimensional array. Okay, so by the reshape. So this is why I always make sure that you understand this reshape step is very commonly used. Okay. Now let me get back to here. Okay. Now after this reshape, then you see that okay, all these numbers will be linearized into the long list of say 28 and 28 of number. But the value of number is 0 to 255, okay, corresponding to the 256 different grade level. Now, this I don't really understand, but what neural network usually work is it requires the input will be a real number between 1 to 0. It depending on the so-called the gradient descent for the improvement of every step. Okay, so basically it will require that all the input has to be between 0 and 1. Okay, so this is rule of thumb. So whenever you try to use a real network, then basically you have to remember that okay, each input will be a number between 0 and 1. Okay, so in order to do that, then we use the okay element-wise say operation capability of TensorFlow, such that I just okay at the end divide by 255, we get a list of number between 0 and 1, such that 255 will be 1, and then 0 will be 0, and then everyone in between will be kind of between 0 and 1. Okay. Now, I want also explain this, okay, about test label. Okay, so this test label originally, if you see, this test label are a number, each label 0, 1, 2, 3, 4, 5. So basically, if you notice is the kind of the training data's model answer, then you would expect that the output of your model answer of the neural network will be give you a number, okay, give you either 1 or 1, 2, 3, 4, 5, and so on, and then 9. Okay, so let's see about that. But this is not possible because what you work on in the neural network is a real number using calculus to do the optimization. So the result is usually is not an integer. It's a real number. So what you get instead of 4, then you will get 4.5 or 1.12, okay, and so on and so forth. Now, this kind of representation causes problem in the classification problem because if you get a number, okay, and even worse, the number that it gives you will be a number between 0 and 1. But anyway, we forget about it. Just a number, okay, that is, if it is 4.5 or 4.4, then do you say it is a 4 or do you say it is a 5? It's kind of very difficult, okay? Sometimes it will give you an answer that is so in the gray area that is very difficult to determine, okay? There's literal kind of error or the between two integer, you will have difficulty to decide what should be the output. Okay, so usually in this classification problem, okay, neural network will not output the label, the number, okay, to represent the class, but instead it will use, okay, very interestingly, an array of 0 and 1, okay, such that each of them will be corresponding to a number A output. So basically, because we have 10, so basically output will be 10 output. Okay, and each will be a number between 0 and 1. Okay, and then the training basically will try to make sure that the output will, on this 10 number, then the correct answer will have the largest number, while the others will be very small. So later you will see that if the image is 5, then for this, say, 10 output, okay, the first 4 1 will be very close to 0, and then the remaining 4 1 will be very close to 0, and the middle value 5 will be very close to 1, or not exactly 1, but maybe 4 or 5, while other is only 0. So the difference is very clear. Okay, so in that case, it will be much easier for us to decide, okay, the prediction. Okay, just out of this 10 number, okay, output, then we just pick the maximum. Okay, so this is what we do. So now what we are doing now is I want to change the problem such that the label now, the model answer, is not the number 0, 1, 2, 3, 4, 5. Okay, the output, the correct answer will be a list of 10, 0, and 1 number. And then if the number image is 0, then the first, okay, entry will be 1. Then all the rest is 0 because it corresponding to the first digit. If this digit is 2, say for example, then the second position of this 10, 0, and 1 will be 1, all the rest will be 0. Okay, so this is the model answer. So this essentially is the label, but it represents in red. Then we can imagine that after this, say, change, then the output will be also a 10 numbers, and the one that have the largest value will be the digit that it predicts. So this is what we need. Okay, so in order to do that, then basically you call this function, because this how to say, this kind of modification are so common. So basically, okay, this Keras provide a standard function called to categorical. Wow, to categorical, okay, such that for every label, okay, this is a training label, originally is a 0 and 1, and then after calling it, it will give you, okay, the categorize. Okay, so let me see, before running it, oh, yeah. So before running it, okay, then the test label, insert row. Okay, so let's just see the test label. You see that the test label, basically, every output is a number corresponding to digit 7. Okay, so now let us say go through this category. Okay, and then okay, then you see that. Okay, so remember, before calling this function, then the first number is 7. Okay, then if you check it, okay, print it out, then I would suspect that, okay, this position, okay, so is now is 9, 8, and this is 7. Okay, so basically the position of 7 is 1, all the rest is 0 to represent that this digit is corresponding to the digit 7. So you see that the original test label model answer is the digit 7. When you do the, say, transformation, basically it changed the digit integer 7 to a, okay, an array of 0 and 1. Such that, okay, for 7 in the first one you see, then all the position will be 0, while the position for 7 is equals to 1, because this is for digit 9, digit 8, and this is for digit 10. Okay, so this is what we have. Okay, so basically what we have to print the training table. Okay, so this up to this point is for preparing the data. Okay, now here is for building the neural network. So basically, this neural network, in order to build it, okay, as I mentioned, we should use the Keras model library. Keras, okay, the model library to build a model. And you will see that this model library allows us to build different models. Okay, we have a CNN model, we have an LSTM model, and more. Okay, so what in this example we are doing is to build a very simple model called a straightforward model. this so-called feed-forward model is the simplest neural network model. Okay, and basically is you build the neural network layer by layer. Okay, and you have an input layer, okay, the bottom of the neural network, and then on top of it, you have another layer of neuron. Okay, later you'll see that another layer, and then connect down your second layer, third layer, so on and so forth. Okay, so how to build it? Here is show you how to build it. So I explain it then. I don't have time to say go through that, but we almost finished. So next time. Okay, so we build a neural network. Okay, the input basically is fixed. Okay, because each image, remember, is 28 times 28. Okay, so the input size is 28 times 28. Okay, while the output is what you have can design. Okay, I decided, okay, the second layer will be, okay, have 512 neuron, okay, while the input shape is 28 times 28, okay, and then it is for the next layer. So let me see. So this is what we're going to have. So here is the for the first layer, which say that this layer, where is it? Okay, have 512 neurons. Okay, 512 neuron. Okay, and then the input shape, the input of this neuron is 28 times 28. So totally you have, okay, the pixel for 28 times 28. Okay, and then each neuron basically is classified as so-called activation, say, function, but we will get to that later. So this is the first layer. Okay, so this line, add layer, basically, it stands means that every output will input X will connect it to one neuron. So it's completely connected. So this is one layer, and this is another layer. For this layer, we have only 10 neurons, okay, and it connect with the output of the previous layer, okay, completely, okay, so fully connected, and this is another layer. So basically, this two line is already built. This two line is already show the design, the architecture of the neural network. Okay, now I'm running out of time here. So up to this point, okay, I just say these two lines to kind of specify the architecture connection of the neural network. But the neural network I need to explain is what it is. It is sometimes called a neuron. Okay, that neuron is the basic unit of neural network. And 520, okay, that means that in this layer we have, okay, 512 this neuron. Okay, but what is the main purpose of this neuron and how it was operated? That maybe we go in this time. Okay, so just make sure you understand just this group. Okay, a line is corresponding to constructing these two layers. Okay, but how this layer is really operated and why this neuron is there and what is its purpose. Okay, then we will get to that later. Okay, so almost finished. Only another step. Okay, so we're running out of time. Okay, so that is that's right. Okay, so about the project again, if you have problem in finding which group, please alert our TA, as soon as possible, so that we can try to figure out the best matching for you. Okay, but of course, it will be best that you can find your own group. Okay.